Hello, dear students. So let's start today's lecture and welcome to our next class of this. This is our sixth lecture of matrices chapter. Until now, we have seen many topics in this, like matrix. What is order of matrix? Then we have covered the type of matrices and operations on matrices, like addition of matrices. Then we have seen product of two matrices, and also the properties of product of matrices and addition of matrices. And then also we have seen what is symmetric and skew symmetric matrix, and how the matrix can be written in the form of skew symmetric and symmetric form. Okay, so let's now start our discussion after that. And this is our third chapter of maths, class 12 NCERT portion. So yeah, let's start it. Till yesterday class, we have seen the this part that n square matrix can be expressed as the sum of a symmetric and skew symmetric matrix. Okay. Now we have one question that express the matrix Q, that is 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3 are the sum of a symmetric and skew symmetric matrix. Okay. So we have to find two types of matrices here. One is like P is written like this, half of B plus B dash, where B dash is what? Your, like, B is your this matrix B1, and B dash is Q. It's you can say that it's you can say what? Adjoint of this matrix. Okay. So you already know that what is adjoint of matrix. And yeah, just a second. No, sorry, this is transpose of a matrix. So I was talking about transpose of a matrix, not adjoint of matrix. Okay. So we can write it like sum of matrix plus its transpose. So transpose is what? Like we have to interchange the row and column elements in the given matrix. Okay. So we will do that that operation here. So half B plus B dash we will find here. So B dash is already written here, that it will be written like this one. This one we replaced in the row. So here you can see that 2 minus 1, 1 is written like this. Then minus 2, 3, 2, 3 minus 2 is written like minus 2, 3, minus 2. And minus 4, 4, and minus 3 written like minus 4, 4, and minus 3. So you have to find first half B plus B dash. So it is what? Half, and B plus B dash is what? 2 plus 2 is 4. Minus 2 plus minus 1 is minus 3. Then it is also minus 3. Here you will get minus 3, 6, 2. Then minus 3, 2, and minus 6. Okay, just add the B plus B dash. Means add this matrix to this one. You will get this result. And after this, you have to divide it by 2. So you will get 2 minus 3 by 2 minus 3 by 2 minus 3 by 2 and 3 and 1. And here minus 3 by 2, 1, and minus 3. I hope you got this, that how I have written this matrix. So this is your P matrix, that is half B plus B dash. Now I have to find another matrix which is half B minus B dash. Just see in the below of this. Here it is half B minus B dash. Okay. So let's delete all this. Yes. Half B minus B dash will be what? Just take the difference of B and B dash and then divided by 2. So you will get the 0 minus 1 by 2 minus 5 by 2 half 0 3 5 by 2 minus 3 and 0. These are the elements of this matrix. Okay. Now just find out your this that is your q dash here. Okay. It is equal to minus q. So after finding out minus q, q will be what? Half b minus b dash is a q square. Because it is coming out equal to minus q, then it is a Q symmetric matrix. So just add P plus Q, you will get the B only. Okay, so we have to write this in as a sum of symmetric and Q symmetric. We have written here like it is P plus Q only. Okay, so that is how it is verified. I hope that you got this point. Let's move to the next exercise, that is 3.3. Okay, so in this exercise, we will see the application part of your that is transpose of a matrix, and also some questions on that operation of that, how the matrix can be written in the form of like symmetric and skew symmetric matrix. Okay, find the transpose of each of the following matrices. So this is very easy question. I hope that you can do this by yourself, because I already told you that what is the transpose of a matrix. If you write it like this one, second one, just interchange the row and column elements. So you will get 1, -1, and 2 and 3. This is your what? Transpose of this matrix. Second question, see the second one. I hope that you can do the other parts of first question, because it is just had to find the transpose of each matrix. So if A is equal to -1, 2, 3, 5, 7, 9, -2, 1, 1, and B is equal to -4, 1, -5, 1, 2, 0, 1, 3, 1. Then verify that A plus B dash is equal to A dash plus B dash, A minus B dash is equal to A dash minus B dash. So this type of question we have done the like your example part. So I hope that you can go to that lecture, that is previous one, and get the idea of this question, that how it is to be done. And I hope that you can do this by yourself. Just find out the A plus B dash. That is, you have to add the A and B matrices here, and then take the transpose. And then you again take the transpose of A individually, and then B. You have to take the B transpose also and add them separately. So you will get like A plus B whole dash equal to A dash plus B dash. Just do it this, you can verify that this is true. Okay, we have done it yesterday. Let's move to the next part, next question. If third question is, if A dash is equal to 3, 4, -1, 2, 0, 1, and B is equal to -1, 2, 1, 1, 2, 3, then verify that A plus B dash is equal to A dash. So this is also similar to the question second one, and this you also can do by yourself. I hope that you can find out it. Fourth question is, if A dash is equal to -2, 3, 1, 2, and B is equal to -1, 0, 1, 2, then find A plus 2B whole dash. So let's do this question. This is also a simple one, but I will tell you that how it is to be done. Let's start. So here, just find out A plus 2B first. Like A dash is -2, 3, 1, 2, then A will be what? Just transpose of this. So what will be transpose of this? -2, 3, then 1, 2. Okay. This is your A plus 2 into B. So 2 into B will be what? -2, 0, 2, 4. Okay. And now you have to add this and take the transpose finally. So just add them. You will get -4, 1, 5, and 6. And take the transpose of whole. You will get -4, 1, 5, 6. So this is your final answer. That is -4, 5, 1, 6. Okay. Simple as that. This is very simple question. So I hope that you can do these type of questions, because these are very simple one, and there is nothing to do there, because you have to take just only the transpose here. For the matrices A and B, verify that AB dash VB whole dash is equal to B dash A dash, where A is this, B is this, and A and B is this. So this type of question is also we have done in the example part, or we have verified that. So you can just go to that lecture and see that. Okay. If you have any doubt in this, you can comment in the chat box. If so one that is A is equal to cos alpha sin alpha minus sin alpha cos alpha, then verify that A dash A is equal to alpha. So we will do this question. This is one property also, that if you take the transpose and then multiply it with the original matrix, you will get it equal to identity matrix. Let's do this, that how it has been like solved here, and we will see the proof of this. Okay. Okay. So first find out the A dash here. You will get it like A dash equal to, just take the transpose here. You will get cos alpha sin alpha minus sin alpha and cos alpha. Okay. Now just multiply it with what? A. So here A is cos alpha sin alpha minus of sin alpha and cos alpha. Okay. You when multiply this, you will get what? Here you just multiply this to this. So it will be cos square alpha plus sine square alpha. Okay. In this row, you will get what? Like in this row and column, you will get cos alpha sin alpha minus cos alpha sin. That is equal to 0 only. Okay. Similarly, here you will get cos alpha sin alpha minus cos alpha sin alpha. This is also 0. And here you will get a sin square alpha plus cos square alpha. That is okay 1. So you will get it 1 0 1 0 1. That is equal to I only. Okay. I of 2 order, 2 cross 2. So that is why it is proved here that A dash into A is equal to identity matrix. Okay, just remember this property, that A dash into A is equal to identity matrix for any matrix. Okay. Second part is also similar to that. You can verify it. Just to do this operation again, you will get the result. Now let's clear this and move forward. 7 question says that show that the matrix A, that is 1 minus 1 5 minus 1 2 1 5 1 3 is a symmetric matrix. So we have to prove here that this matrix is a symmetric matrix. Okay. How to prove that this is a symmetric matrix? Just take the transpose. If it is coming equal to A, then will be what? Symmetric matrix. So I will take the transpose here. So just write the transpose. When you interchange the row with the column, you will get 1 minus 1 5. Then here you will get minus 1 2 1. Then here 5 1 3. See here 1 minus 1 5 minus 1 2 1 5 1 3. This is identical to the A matrix, so it will be what? This is a symmetric matrix because it is equal to A only. And if you take A dash and it is coming out to equal to A, then it is a symmetric matrix. We have already covered this portion. Okay. Similarly, the second example is telling us that show that the matrix this is a skew symmetric. So you have to find out here what? A dash only, and it will come equal to minus times of A. So this will show that this is a skew symmetric. Okay. I hope that you can solve it by yourself, and I leave it for you because it is a simple one and you can refer it by seeing the previous lecture also, because I have already clearly mentioned you that what is a symmetric and what is a skew symmetric matrix. Okay, so let's move to the eighth question. For the matrix A that is equal to 1 5 6 7, verify that A plus A dash is a symmetric matrix, A minus A dash is a skew symmetric matrix. So that also we have done today also, that A plus A dash is always a symmetric matrix and A minus A dash is a skew symmetric. This is covered in the previous lecture also, so you can go and watch there. So I will not tell this question because this is a simple one. You just find out these values and you will find out that these are symmetric and skew symmetric respectively. Okay. So let's find out the next question, that what it's tell. Nine question says that find half into a plus a dash and half into a minus a dash when a is equal to this. So that is also covered today. You just have to find out here half a plus a dash. Okay, so take the like transpose here and add them, then take the half of that, and also you have to again subtract the transpose from original matrix and take the half of that. So you will find out that first one is your symmetric and second one is symmetric. Okay. Okay, 10th question is there. Express the following matrices as the sum of a symmetric and a skew symmetric matrix. So this is obviously similar to the previous one, and we have done this type of also that any matrix can be written as the sum of half a plus a dash plus half a minus a dash matrix. Okay, and one of them is a symmetric, another is a skew symmetric. So just give this by seeing that. If you have any doubt in this, we will see this in the comment. If like you post it in the comment, I will solve this for you. 11th question says that choose the correct answer in exercises 11 and 12. So there are like some options there. This is the objective type of questions. So we have to choose the correct one in this option. Let's just see that what these questions say here. If A, B are symmetric matrices of same order, then AB minus BA is the. So if AB are symmetric matrices of same order, okay. So we have to find tell that what is AB minus BA. So let's take the example here. Okay, A matrix I will take as 1, 1, 1. Okay, and B matrix 2, 2, 2, 2. Okay, and if you find out here AB minus BA, then it will be what? AB will be what? You will see that AB and minus BA is your symmetric matrix or symmetric or zero or identity. Just take the product of here. So you will get what? 2 plus 2. Then it is also 2 plus 2. Here also 2 plus 2. And here also 2 plus 2. Okay. So what are you getting here? 4, 4, 4, 4. This is also what? Your symmetric matrix. Okay. So what you are getting here? Symmetric matrix only. So this option will be correct. Now, for 12th question says that if A is a cos alpha and sin alpha cos alpha, that A plus A dash is identity matrix if the value of cos like alpha is. So just find out here A plus A dash, you will get the value of A alpha. Okay. So A dash will be what here? A dash will be cos alpha minus sin alpha. Okay. Sin alpha and cos alpha. Now take the addition of A plus A dash, you will get here 2 cos alpha, here 0, here 0, and here 2 cos alpha. Okay, this is the identity element or matrix. So 2 cos alpha must be equal to 1. So alpha equal to what? Half. So what is the like cos alpha is half. Then alpha value should be equal to what? Pi by 3 only. Okay. So what is the answer? Pi by 3. B option is correct. So this is the like end of this exercise. Now let us move to the next topic. What are these topics? Because we have already seen that what are the what are symmetric and skew symmetric matrices and what is transpose of matrix. Then we have seen some examples of that in the exercise. Also, we have seen some questions on these topics. Now we will move forward to the next thing, that what is the next here. I hope that you all understood whatever I told you today and teach you about these things. So yeah, let's move forward. Elementary operations, that is transformation of a matrix. So there are 6 operations, transformations on a matrix. three of which are due to rows and three due to columns. So you can uh, do some operations on the matrix, and there can be six types of operations: three for columns and three for rows, which are known as elementary operations or transformations. Okay, the interchange of any two rows or columns, the interchange of any two rows or two columns. So symbolically, the interchange of ith and jth rows is denoted by ri is changing to rj. And interchange of I and jth column is denoted by ci changes into cj. Okay. So if you want to apply R1 is changing with exchanging with R2 to A, then it will be what? Your row 3 will R1 changing to R2, sorry. So it will be what like operation your R like row 2 will be shifted to row 1 position and row 1 will be shifted to row 2 position. So you will get it like 1 to 1 minus 1 root 3 1 5 6 7 as minus 1 root 3 1 and 1 2 1 and 5 6 7. So this is your like interchanging of two rows or two columns. The second operation is multiplication of elements of any row or column by a non-zero number. Symbolically, the multiplication of each element of the ith row by k, where k is not equal to 0, is denoted by ri is multiplied by k. Okay. So if you uh, and corresponding column operation will be denoted by what? Ci is equal to k into ci. For example, if you apply like column 3 is changing to 1 by 7 of column 3 to b, like b is a matrix, so 1 to 1 and minus 1 root 3 1, then it will change into 1 to 1 by 7 and minus 1 root 3 1 by 7. See here, you can observe that your column 3 is divided by 7 here. This is also 1 by 7, this is also 1 by 7. See here, 1 by 7, 1 by 7. So you can see that one operation is applied here in the third column. Similarly, you can apply any operation on like particular row and column. Okay. Now, what is the third property here or third operation? So the addition of the elements of any row or column, the corresponding elements of any other row or column multiplied by any non-zero number. So we have to do the addition of two elements of any row or column, the corresponding element of any other row or column multiplied by any non-zero number. Symbolically, the addition to the elements of ith row, the corresponding elements of jth row multiplied by k is denoted by ri is equal to ri plus krj. Okay. So what you can do that if you have your column ci, then it can be changed into ci plus kcj. For example, here we will apply R2 is equal to R2 minus 2R1. If you see the matrix 1, 2, 2 minus 1, then we can change the second column of this or second row of this change into what? Like row 2 minus 2R1. Means we have here done that. We have taken the difference of column 2, row 2 with 2 times row 1. Here, 2 minus 1 are the elements in the row 2. Okay. So I will do what? 2 minus 2 times of row 1, that is 1. This element. Okay. 2 times of this. So it will become 2 minus 2 into 1 and it will become minus 1 minus 2 into 2 because 2 is there. So what are the elements we will get here? Like 0 and minus of 5 here. 1, 2 was already there and 0 minus 5 we will get. There will be no either change of anything if we do this operations. Okay. These are some operations on your matrix, original matrix. Okay. Now we will see what are invertible matrices. Okay. Just we have covered the operations on matrix. Now we will see invertible matrices. If A is a square matrix of order M, okay, If A is a square matrix of order M and if there exists another square matrix B of the same order M such that AB is equal to BA equal to I, then B is called the inverse matrix of A and it is denoted by A inverse. In that case, A is said to be invertible. Okay, so that is the definition of invertible matrices, that if you have any matrix B that you multiply with any original matrix A, then you will get AB is equal to BA. Means AB multiplication is equal to BA. That is both inverse are here equal, and that is coming out equal to I. That is identity matrix. Then B is called the inverse of matrix of A. So B will call what? Inverse of matrix A, and it is denoted by A inverse. That will be the uh, denotion of that A inverse. In that case, A is said to be invertible, and A is that what? Invertible matrix. For example, let A is equal to 2, 3, 1, 2, and B is equal to 2 minus 3 minus 1, 2. Be two matrices. If you multiply here with 2, 3, 1, 2 with the 2 minus 3 minus 1, 2, what you will get here? See, just multiply them. You will get a 2 into 2, that is 4, and minus 1 into 3. So 1 in the first position, then minus 6 plus 6, that is 0, then 2 minus 2, that is 0, and then 1. So it is coming out equal to the identity matrix. Okay, so here the BA is coming out to be a 1 0 0 1. AB is also 1 0 1 0 1, and you will find out that BA is also coming out equal to 1 0 0 1. That is equal to identity matrix only. Thus B is the inverse of A. In other words, B is equal to A inverse and A is the inverse of B, that is A is equal to B inverse. I hope that you got this type of question, that how we can find out whether the matrix given is a invertible or not. Okay. There are some points in the notes that a rectangular matrix does not possess inverse matrix sense. For products B and AB to be defined and to be equal, it is necessary that matrices A and B should be square matrices of the same order. Okay, so that is not possible for rectangular matrix, because you will not get identity matrix there, and for identity matrix to be find out, you must have the matrix as square matrix. If B is the inverse of A, then A is also the inverse of B. That is also true. If A is the inverse of B, then B is the inverse of A only. Theorem 3, uniqueness of inverse. So there is a theorem 3 here which says the uniqueness of inverse. Inverse of a square matrix, if it exists, is unique. So it is said that inverse of any matrix is unique only. Okay. If it exists, it is it is unique. Let A is equal to Aij be a square matrix of order M. So here is A any matrix that is written as Aij. It is a square matrix of order M. Okay. If possible, let B and C be two inverses of A. So here let B and C are two inverses of A. So we will assume that B and C are two inverses of A. Okay. So AB is equal to BA, that is equal to I. Since since C is also the inverse of A, then AC is equal to CA, that is equal to I only. Then B is equal to BI. So B is equal to BI here, that is equal to B into AC. Okay, because B can any matrix can be written as product of this matrix with identity matrix. So B is written here like what? B into I, and I value is coming out equal to AC, and we can write B into AC as BA into C, and BA is what here? I only. So IC is coming, that is equal to B is coming equal to IC, and that is will be equal to what? C only. So it is proved that there cannot be two different inverses of a single matrix. If A and B are invertible matrices of the same order, then AB whole inverse is equal to B inverse A inverse. Okay, so that we can prove also. Truth is that from the definition of inverse of a matrix, we have AB into AB inverse equal to 1. Okay, or I. Like if you have any matrix AB and its inverse, AB inverse. So if you multiply it, you will get what? Identity matrix. And if you multiply it both sides with inverse, A inverse is multiplied here. Okay, so this is AB, this is AB inverse. Here also A inverse will be multiplied both sides, multiplied here also. So you will get what? You can write it like A inverse A, okay, into B and AB inverse. That is equal to A inverse only. So what is this? This is your like I only I into B into AB inverse. Yeah. So it is equal to A inverse. Or it is coming out equal to IB is equal to B only, and this is AB inverse equal to A inverse. Okay. Now just multiply it by B inverse both sides. So B inverse will be multiplied to both sides. Okay. And this is AB inverse. This is B inverse A inverse. Now it is coming out equal to I, but this will become I only, and AB inverse. That is equal to A B inverse and A inverse. B inverse A inverse. Now I into AB inverse will be AB inverse only. This is equal to B inverse A inverse. So we have proved this, that AB inverse is equal to B inverse A inverse. So that is very like easy proof. You just have to multiply the inverse of following like matrices which are written here. Like A is multiplied initially with A inverse. Then when B in the forward, like in the first position, you have to multiply it with B inverse. Okay, you can multiply like this to many type, like in numerous number of matrices written like this. Inverse of a matrix by elementary operations. So just we have seen that what is the inverse of a matrix. We can find out it by elementary operations also. Okay. So how we can find out it? Like let's see that what is the like main motto of this. Let X A and B be matrices of the same order such that X is equal to AB. So if we have X is the product of any two matrices, that is AB, in order to apply a sequence of elementary or row operations on a matrix equation. Okay. So yeah, elementary row operations on the matrix equation X is equal to AB. We will apply these row operations simultaneously on X and on the first matrix A of the product AB on RHS. Okay, so we will like apply row operations. If we start from row operation, then we will apply it continuously on X and first matrix A of the product AB on RHS. Similarly, in order to apply a sequence of elementary column operations on the matrix equal equation X is equal to AB, we will apply these operations simultaneously on X on the second matrix B of the product AB on RHS. So, like if we have to apply a row operation, then we will apply it on first matrix A, and if we have to apply column like operation, then we will apply it on second matrix B. In view of the above discussion, we conclude that if A is a matrix such that A inverse exists, then to find A inverse using elementary row operation, write A is equal to IA and apply a sequence of row operations on A equal to IA. Till we get I is equal to BA. Okay. So we have to apply like a sequence of row operation here till we get what I is equal to BA. The matrix B will be the inverse of A, and here B will be what? Inverse of A. Similarly, if we wish to find A inverse using column operation, then write A is equal to AI. So if like you have to find out uh, your A inverse using row operations, then you have to write A is equal to IV. And if you have to find it out by column operation, then A equal to AI should be written. And apply a sequence of column operations on AI is equal to AI till we get I is equal to AB. Okay. This is like how you can find out the inverse of a matrix using elementary operation. In case after applying one or more elementary row column operations on A is equal to AI, A or A is equal to AI, if you obtain all zeros in one or row one or more rows of the matrix A on LHS, then its inverse does not exist. Okay. Like if you are applying the your elementary operations on both sides, if you obtain all the zeros in one or more rows of the matrix A on LHS, okay, like all the elements of one row or more than one row are coming out to be equal to zero, then your inverse will not exist here. Okay. By using elementary operation, find the inverse of a matrix A is equal to 1, 2, q minus 1. So we here in one example, that is we have to find the inverse of a matrix A, that is 1, 2, 2 and minus 1. So let's see that how we can find it out by using the elementary row operation. Okay. In order to use elementary row operation, we may write it A is equal to IA. So that we have already talked about, that if we have to do row operation, we should write A is equal to IA. Okay. See here. Now 1, 2, 2 minus 1 can be written as 1, 0, 1, 0, 1 and into A. Okay. Then 1, 0, 2, 1, 2, 0 minus 1 is equal to, okay. So here you can apply what? R2 is equal to R2 minus 2R1. Just change this R2 is equal to R2 minus 2R1. Then here in the right hand side, you have to apply this operation simultaneously to this also. R2 minus R2R1. Okay. Which operation you apply here, the same operation should be applied here also. So what you will get here, 1, 2, it will become 0 and minus 5. Because here your R2 is changing by R2 minus 2R1. So 2 minus 2 into 1, this is first value. And the second element you will get minus 1 minus of 2 into 2. Okay. So you are getting what? 0 and minus 5. 0 this one, and this is minus 5. Okay. And here in the right hand side, you will get what? 1, 0, minus 2, 1. Similar operation. Okay. So that is the first step. Okay. What is the next step? Then you have to apply R2 is equal to 1 minus 1 by 5 R2. Okay. So your R2 is changing into minus 1 by 5 for R2. It means that it will be divided by minus 5 both the sides. So your left hand side will become 1, 2, 0, 1, and right hand side will become 1, 0, 2 by 5 and minus 1 by 5. Okay. So in the third operation, we will apply your R1 is changing into R1 minus 2R3. Okay. It means that you have to do it what? Your R1 is, this R1 is changing into your R1 minus 2R2. So 1 minus 0 and 2 minus 1, 2 minus 1 into 2, that is 1 and 0 will come here. Okay. And here 0 and 1 will come. So see here, you can see. And here also you will get 1 by 5, 2 by 5, 2 by 5 and minus 1 by 5 into A. So you have seen that this left hand side is coming equal to I. So this is the form of I is equal to your BA. So this must be equal to what? B is equal to A inverse here. So A inverse is coming out to equal to 1 by 5, 2 by 5, 2 by 5 minus 1 by 5. This is your final answer. I hope that you got this question, that how we have done this by elementary operation, row operation. You can find it out by column operation also. We will like see this in the alternative method. So just what you have to do, in order to use elementary column operation, we can write it A is equal to AI. Okay. So 1, 2, 2 minus 1 can be written as A into 1, 0, 0, 1. Then apply C2 is equal to C2 minus 2C1. So you have to do what? Your column 2 is changing into C2 minus 2C1. Like this column will change into what? 2 minus 2 times 1, then 1 minus 2 times 2. So you will get what here? Here you will get 0, and here you will get this second 1 and minus. Yes. Yeah. Here you are getting 1 minus 2 minus 2 into 1, and in the second you are getting 1 minus 2 into 2. So what is this? 1, 2, 0, and so here it should be what? Minus 3 only. So here they have written 1, 2, 0, minus 5. So I think that here they have mistakenly written like this only, but here should be minus 3. Okay. So you can find out the inverse of this by this column operations. Just to move forward, and you will see that you can easily find it out. Okay. I think they have written here something wrong, because it is 1, 2, 2, 1 is only there. Okay. Just I have to see the original matrix here. Okay. 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 Just a second. Yeah, they have done correctly here. Minus 1 times minus 2 times 2, that is equal to minus 5 will be there. So 1, 0, 2 minus 5 is there. That is equal to a into 1, 0 minus 2 and 1. Similarly, after that, you will do C2 is equal to minus 1 by 5 C2. So you will get this and this. Okay. And after that, you will have to do what? Finally, you have to apply C1 is changing into C1 minus 2 C2. So this C1 will change into C1 minus 2 C2. You will get 1, 0, 0, 1, and 1 by 5, 2, 5, 2 by 5, 2 by 5, 1 minus 1 by 5. So you are getting like this only. I is equal to A, B. So here your B should be A inverse. Okay. So that is coming equal to what? The that you have done in the row operation. Okay. So both the answers are coming equal, and this that should be equal because the answer is only unique here. So I hope that you got whatever I told you today. And till now we have seen that what are your transpose of matrix, and what is a symmetric matrix and skew symmetric matrix. Then we have seen that what is the your invertible matrix, and some like properties of this invertible matrix. Okay. How to do the elementary row operations and elementary column operations for finding out the inverse of a matrix. So these all we have covered today, and I hope that you like the today's session. If you have any kind of doubt or any type of suggestion, you can write it down in the chat box, or you can ask from us. If you also want any type of one-to-one session or private session from us, you can also tell us. Okay. So thank you for today's lecture. Have a great day.